Okay, here is the other partial fraction decomposition problem. We're going to do number 3 now. So again, we need to factor the denominator first. So this takes a little bit more work. We've got to be a little bit more careful with our factoring. So if we think about, I'm just going to write it over here first, just the denominator. We'd have to take out an x first. We'd have x squared minus 2x plus 1. If we factor that more, hopefully we're going to get to x minus 1 and x minus 1. No good mathematician is going to write x minus 1 and x minus 1. They're going to write x minus 1 squared. So all of this ends up being 3x squared minus x plus 5 over x times x minus 1 squared. So this is a little different than the other one. We actually are going to have more than 2 fractions because we have to do each linear factor raised to each power that it has. So here's what I mean. We know that one of our linear factors over here is x. We know another linear factor is x minus 1, linear, okay? But then we have to raise it to each power, so we are going to have also x minus 1 squared. So here's 3 variables, so you can probably think ahead and think, oh, we're going to have a 3-variable system. Makes sense why it's in this chapter with our 3-variable systems, our matrices, all of that stuff. Do understand that if you had like cubed here where the squared was, you'd also have cubed. If you had to the fourth, you'd also have to the fourth. Like you could have a whole bunch, but that would be less effective as far as solving by hand. So let's go ahead and think from here like we did on the last one. What do we do next? Well, we don't want the fractions, so let's clear the denominator by multiplying by the least common denominator. So the least common denominator of everything is definitely going to be, this over here. Let's erase that. Okay, so if we're going to multiply everything, and space-wise, I can't really fit it to the left there, so I'm going to write it over here to the right. I know it's a little weird, but it's not matter. We're going to distribute this x times x minus 1 here, which is effectively just going to get us 3x squared minus x plus 5. When we distribute here, think x and x no longer, so we'll simplify it to 1, so I'll have a times the x minus 1 squared. When I distribute here, one of the x minus 1 factors will go away, so I'll have b times x times 1 of the x minus 1s. And when I do this one, x minus 1 squared will simplify to 1, so I'll just have cx. So kind of messier than our last example. Just a lot more algebra to do. So from here, x minus 1 squared, I have to be able to do that. So again, let's write everything out, make sure we're on the same page. X minus 1 squared means x minus 1 times x minus 1. So if you think about that, we've got a FOIL. If you need to write that out, write it out. But we should have x squared minus 2x plus 1 out of that eventually. Here, let's go ahead and distribute as well. So we'd have bx squared minus bx plus cx. Do one more step of distributing. And then it's just going to seem like we have a huge mess, but we don't, because we are going to make sure I did that right. Ax squared minus 2ax plus 2 plus bx squared. We're going to group things together. We kind of did this on the last problem if you watched the last video. We need to put maybe our x squared things first, then our things that just have x, and then our things that don't have x. And this one almost helps you see that better since there's more going on. So again, we're not even doing anything with the left-hand side, it just keeps coming along. But over here, let's put anything that has x squared first, so ax squared plus bx squared. Then next, let's put anything that has x, so minus 2ax minus bx plus cx. And then don't forget about this a right here in the middle. So I've just effectively reordered everything. Now I'm going to do some factoring. So I need to look at this and think about factoring out the x squared. So I know what that coefficient is that's going to be equal to our 3 over here. So again, this side's not changing at all. If I take out x squared from both of these and I write it back here, well, what do I have left? Well, if I factor out the x squared, I'd have a plus b. So in effect, 3 is going to be equal to a plus b. That's going to be one of our equations here in our system eventually. Okay, we got to do the same for all of it though. So let's keep going. Right here, I'd say this is, here, I'm even going to highlight it. This is a little bit trickier. I personally would make a plus sign right here, and then I'd leave all the signs the same so I don't have to think about a negative or something. Because then again, if I'm factoring out x, well, I then literally have negative 2a minus b plus c in there. If you think about multiplying that back out, I would get the negative 2ax, the negative bx, the positive cx, like that plus sign just is kind of a placeholder. And then plus a. Now I already have it underlined over here. Everything's set up the way I wanted to. So 3 is equal to the a plus b, because that's both what's the coefficient of x squared. This is an equal sign. These have to be equal. Okay, another one then. This right here, which is a negative 1, has to be equal to the negative 2a minus b plus c. So negative 1 equals negative 2a minus b plus c. And here is the best one this time. Let's find a fun new color. Oh, none of them are that fun. Ooh, purple. 5 is equal to a. Well, that gives us part of our answer right there. 5 equals a. Great. So yeah, this is our system, but some of it's already solved. If 5 equals a, can't I just go ahead and substitute in right here to figure out b? Well, sure. So b must be negative 2. And then let's go ahead and substitute both of those into the middle green equation and see what c is equal to. So I'd have negative 1 equals negative 2 times 5 minus negative 2 plus c. So it looks like in the end here we get negative 10 plus 2, so negative 8 plus c. We add the 8 over, so c equals 7. So it's like, okay, great. Again, we're like, we've got a is 5, b is negative 2, c is 7. We got to scroll way back up here, and that's what we're writing in effect in our answer right here. Right? And I'm even going to be super cool since this thing is so cool. Highlighted is going to be our answer, okay? Because I don't have a lot more space. So I am simply going to, ooh, I don't know if it's going to work. We're going to find out. Erase that, and that. And it looks like I'm going to have to re-highlight in a second. So I've effectively erased the A, B, and C. And I'm going to put in what we got for A, B, and C down below. So A, we got, see if I can remember them. Nope, they go away? No, they didn't go away. They're down here. A, we got 5. B, we got negative 2. C, we got 7. So A is 5, negative 2, 7. Come back up here. 5, negative 2, 7. That, I'm going to highlight it back in, is the answer to the whole problem. That's what we're trying to figure out. We're trying to figure out what 3 fractions added together get me the original thing. So this is the partial fraction decomposition of that problem.